All right, guys, so we are looking at section 4.4. This is on page 93, like I said. So first of all, we're going to look at some definitions here. Factored completely. So how do we know when a factor is factored, when a polynomial, rather, is factored completely? The way that we know that is when the polynomial is written as a product of unfactorable polynomials. Some common factors that we might see that are unfactorable would be x squared plus 4. A lot of times people think, well, isn't that factorable? No, it's the sum of two squares. It's the addition of two squares. This cannot be factored further. But if it had been x squared minus 4, that's the difference of two squares. X squared minus 4 goes down to x plus 2, x minus 2. So this would be something that's unfactorable. Other things that might be unfactorable, we could have a quadratic, like x squared plus 4x plus 5. I would look at this, I would say, are there numbers that multiply to be 5, 5 and 1, but do they add to be 4? And no, they don't. So this would be unfactorable. So we would not take it down any further. So these would just be a couple of examples of factors that would be completely factored, can't do anything more with them. The next thing we're going to look at is factoring by grouping. We're going to use this when there are pairs of terms that have a common monomial factor. I'm going to show you an example of this. This would be as if we have AB plus AC plus MB plus MC. So we use this method, this factoring by grouping, when there are pairs, meaning two, of terms are always separated with a plus or minus, that have a common monomial factor. Monomial just means any of these things that I'm going to write. It could be just an A. It could be just a B. It could also be 3b squared. All of those are examples of monomial factors. X plus 2, x squared plus 4, this is a binomial. This is a trinomial. So monomials are only a single term. So let's look at this little example here. I look at this first pair. What is the monomial that I can factor out? Charlie?
A.
So I would take an A out, and I'm left with B plus C. Then I look at my second pair. Right here's my second pair. What can I factor out of there? Haley, what can those have factored out?
M.
So I would take out M, and if I do MB divided by M, that's B, plus MC divided by M, that's C. Now I look at what I've got. This is one term. Here's a plus. Here's the other term. So now what do those two terms have in common? B plus C. So now I can take out a B plus C. If I factor a B plus C out of here, I'm just left with A, plus, if I factor a B plus C out of here, I'm just left with M. So that's what we mean by factoring by grouping. We have four terms. These two have a common monomial factor. These two have a common monomial factor. Then I look at these and I say, what's its common factor? I factor that out, and then whatever's left. Quadratic form. This is when I have AU squared plus BU plus C. Let me show you an example of this. Maybe I have something like, let me make one that's not too difficult. Let's say we've got x plus 4 squared plus 3 times x plus 4, and then minus 4. See how this can be written as u squared plus 3u minus 4? That's how that could be written. So what if I just tried to factor this? Well, I'd set up my double parentheses. This is u, this is u. What are numbers that multiply to be 4 and subtract to be 3? Multiply to be 4 would be 2 and 2, 4 and 1. Which of those subtract to be 3? 4 and 1, so we're going to use a 4 and a 1. I have to have a positive 3, so this is plus, this is minus. I double check, u squared, those give me 3u. My last times my last gives me that. But that's how this would factor. This is u squared plus 3u minus 4. So I have to change my u now. So I have to change my u into x plus 4. So this would now turn into x plus 4 times x plus 4 minus 1. So really this would factor down into x plus 8 times x plus 3. That's how this whole thing would have factored out. Well, you also could have just multiplied this whole thing out. I could have made this x squared plus 8x plus 16 plus 3x plus 12 minus 4. You see what I'm doing? Squaring this, distributing. So this is really going to be x squared, 8x plus 3x is 11x, 16 plus 12 is 28, minus 4 is 24. So I could have multiplied this whole thing out, and then how does this factor? What are numbers that multiply to be 24 and add to be 11? 8 and 3, right? See how I'd get the same answer? But maybe it was a little bit easier this way, right? Thinking of it as u's. So that's another thing we can do. These are two new formulas that you need to be able to apply. The sum and difference of two cubes. A cubed plus b cubed is always going to be a plus b times a squared minus ab plus b squared. Very important formula. Here it is being used. In this case, whatever the cube root of 64 is, the cube root of 64 is 4x. I'm sorry, is 4. Cube root of x cubed is x. So my a is 4x. My b, the cube root of 1, is just 1. And now we apply the formula. So it's a plus b, a squared minus ab plus b squared. See how that worked? The difference of two cubes is very similar, except this one is now going to be these signs change. So the plus is minus, the plus is minus. The minus is plus, but the last sign always remains a plus for both of them. So in this case, a would be 3x, b would be 2. Applying our formula, it's a minus b, a squared plus a times b plus b squared. Some people like to memorize these individually. Some people prefer to just have one formula. If you like just having one formula, you can write it like this. A cubed plus or minus b cubed is always going to be a plus or minus b, a squared minus or plus ab plus b squared. All right, so let's do this one together. First, we have to identify our a and our b. Daniel, can you tell me what a would be?
A would be 1,000.
What's the cube root of 1,000?
That would be 10.
Right. So our a is going to be 10, and then the cube root of x cubed is x. Max, what would our b be? What's the cube root of 27? 3. So now we apply our formula. We're using the pluses. So see how the pluses go? If it's plus here, then it's plus here, but it's going to be minus here and plus here. See how the signs go? Plus, minus, minus, plus, and then plus. So here's how this is going to go. A, I'm using a plus, so I use a plus, plus b, a squared. Haley, what's a squared?
100x squared.
Good. And then if this is a plus, that was a plus, this should be a minus. And then I have to do a times b, which is 30x, and then plus, and then we have to square that. And here's the other nice thing about cubes, is that this factor here can never be factored further? A lot of times people look at that and they're like, well, sure, that could be factored further, but let's try it. Just off to the side here, let me show you. Don't even write this down, just watch. If you try to factor this further, it'd be 10x and 10x, 3 and 3. And you think, well, if I just put minuses here, that works, doesn't it? Well, 10x times 10x is 100x squared. Negative 3 times negative 3 is positive 9. But look at the outers. This is negative 30x, and this is negative 30x. That's going to give us negative 60x, isn't it? Not negative 30x. So that's why this can never be factored. It will always just be what we call a prime factor that can't go down any further. All right, let's look at example 2 now. Let's identify A and B together. Jessica, what's the cube root of 8x cubed? Now the cube root of 8 means what times what times what is going to be 8. So it's going to be 2x. And then the cube root of 125. Andrea, what's the cube root of 125? 5. And the cube root of y to the 6th. Anyone know that? What is it, Nathan? 1. And here's why. If I want to check it, I do 5y squared times 5y squared times 5y squared. If that's the cube root, 5 times 5 is 25 times 5, 125. Y squared times y squared is y to the 4th times y squared, that's y to the 6th. So that did work. So that is the correct cube root. All right, so now try to write it, guys, using your formula. You're going to use the subtraction, so you're going to use all the bottom values. Yeah. No, because in the formula takes care of the minus, so we really just want to keep it as a positive. Taylor, do you have it? Okay. Just tell me when you're ready. Keep going. Very good. It's y to the 4th there. So she did a minus b, a squared plus ab plus b squared. This is 25y to the 4th. All right, let's go over to the next page. A little more factoring. Top part of this we'll be doing tomorrow, so let's go down here. When we're trying to factor completely, the first thing we're always going to look for is a GCF, a greatest common factor. So let's look at that on example 1. Is there a number that 20, 220, and 600 can all be divided by? What is that, Zach? 20. So I'm going to take out a 20. What else? X, right? So 20x. So what I'm left with then, 20x cubed divided by 20x is going to be x squared. 220 divided by 20 is 11x. 600 divided by 20 is 30. So now I want to see if this can be factored further. Here's the way I do it. I look here first, and I say, are there numbers that multiply to be 30 that add to be 11? You can just read it backwards. Zane, what are they? Good. So I'm just going to bring down my 20x. I set up my double parentheses. I'm going to do x and x. The numbers that multiply to be 30 are 6 and 5. I needed them to add to actually be a negative 11, so they both have to be negative. And then I just double check. X squared, outers, inners work. The last times the last gives me positive 30, so we're good. That's it. Let's look at the next one. The first thing we always look for is a GCF, always. So what is our GCF going to be there, Zach? So we're going to take out an m. And I'm left with m to the fourth minus 81. So now I'm going to keep going. I bring down my m. Another thing I always want to look for is I want to look for a trinomial that goes just down into like this, x minus b, x, let's say plus or minus. So I look for something like that. That's what we did here. But I also want to look for this, the difference of two squares. Difference means subtraction, and then two squares means that both of these are perfect squares. See this? The difference of two squares, so I can factor this. I look at m squared, m squared. Anybody know the pattern for the difference of two squares? Right. And that's because we want these outers and inners to end up being 0 because we don't want an n squared term. And positive 9 times negative 9 gives us negative 81, so that's good. But now I have to see if I can do anything more. The sum of two squares can never be factored down further, so that's done. But this is the difference of two squares again. So we have to take that down further. Shane, how's this going to factor?
M minus 9 and M plus 9.
Close. M minus
3.
That's okay. M minus 3, M plus 3. There we go. All right, so we look for these three things. We've had these three types. Another thing we can look for is the sum or the difference of cubes. The sum or the difference of cubes. Let's look at number 3. Right there it is, isn't it? That's the sum of two cubes. See how this is a perfect cube, this is a perfect cube, everything's a perfect cube? McKenna, what's going to be A and B? Good. Can you remember it without looking back at the formula, how it's going to go? Or you can look back if you need to. And McKenna, just tell me when you're ready. You're really close. The only thing that I think you need to change is right here. When you said plus, this has to be minus, okay? And this one's always a plus. So these two are always the opposite of one another. This one's always a positive. And to figure out what the first one is, it always matches what it was at the beginning. Okay, so I just always think of that. These match, flip, and then go back to positive. Want to see it again? These are the same, change, and then always positive. All right, number 4, guys. First thing we always look for. Yeah, actually, let's go down to 6 first. It's easier than 4. Let's do 6 first. So first on number 6, again, look for that GCF. It's 5. So I'm going to take it out, the 5, and I'm left with p cubed plus p minus p squared minus 1. So I took out my 5. So now I'm going to keep going with the grouping. So out of these two, I can factor out a p. So out of those two then, I'm going to be left with a p, and I've got p squared plus 1. Out of these two, I can't really factor anything out, but I have to take out something. So I'm going to take out a minus because of this minus. So I'm going to take out a minus 1. And I'm left with negative p squared divided by negative 1 is p squared. Negative 1 divided by negative 1 is plus 1. This 5 just gets carried down. Now, looking at this and this, what do these two both have in common? Everybody? So I'm going to take out a p squared plus 1, and then what I'm left with is just a p minus 1. And this cannot be factored further because it's the sum of two squares. It would have to be subtraction to be able to be factored down further. All right, now let's go back up to 4. Whenever we see 4 terms, we're thinking of this last method of grouping. So grouping is only if we have 4 terms, because we have to have a pair of pairs. Okay, so what about out of the first two? Henry, what can I do at the very beginning, though? Take out what? More than that. All right, so I'm going to take out t cubed, use these brackets like this. I'm going to have a 5t to the third plus 2t squared minus 5t plus 2. Minus 2, rather. Sorry. Minus 2. All right, so I'm going to bring down the t cubed. I'm looking at the first two to start. Grace, what can I factor out of the first two?
T squared.
Good, so I take out a t squared, and I'm left with 5t plus 2. Gina, what can I factor out of the next two? All right, so I'm going to take out a negative 1, and I'm left with 5t plus 2. If I've done this correctly, these two should match. If they don't match, then something's wrong. Now this t cubed just gets brought down. So out of these two, I have a 5t minus 2 in common that I'm going to factor out. And then I'm left with a t squared minus 1. Can t squared minus 1 go down further? Yes, it can. So this is going to have to be t cubed times 5t minus 2 times t minus 1 times t plus 1. That will be our final, most simplified answer. All right, let's go back over here to number 5. This is a trinomial. So for a trinomial, I'm just trying to factor it like this. Just trying to factor it. And this is quadratic in form. So I know it's going to be y squared and y squared. I look here. What are numbers that multiply to be 48? You're probably thinking of what? What comes to mind immediately? 6 and 12, or 4 and 12 and 6 and 8 probably come to mind. Do 4 and 12 subtract to be 13? What about 6 and 8? No. So here's what I can do. For 6 and 8, I'm going to break this up. It's 3 times 2, and this is 4 times 2. So I can use any combination. So I can see the 8 times 6, but what about 2 times 4 times 2? What's that? 16 times 3. So 16 times 3 is also 48. Do those subtract to be 13? That's what we need to use. 16 and 3. I need to get a negative 13 with those outers and inners, so which one's negative? 16's negative, 3's positive. I look at this. This cannot go down any further, but this can. It's a difference of 2 squares. So y plus 4, y minus 4, and then y squared plus 3. Any questions there? All right. Let's flip over to the next one. These are our last couple problems here, 11 and 12. First thing I look for in 11, GCF. What is it, everyone? 2. I'm going to take it out. I've got 6x squared minus 11x minus 10. Now, if I want to see quickly if this can be factored further, I multiply the first times the last, just the coefficients. So 6 times 10 is going to be 60. Are there numbers now that multiply to be 60 and subtract to be 11? What are they? 15 and 4, good. You may not have thought of that. I'm sure most of you were thinking of 6 and 10, right? That's what comes to mind usually. We'll break those apart. 3 and 2, 5 and 2. So now I can see that I can also use 15 and 4. So 15 and 4 are the ones that do work. That means this can be factored more. If there weren't any numbers like this that multiply to be 60 and subtract to be 11, this would be prime. But I can keep going, so I'm going to try it. So I'm going to do 3x and 2x. What are my only possibilities for numbers that multiply to be 10? Well, there's actually 2, but 2 and 5. Here's a hint. You will never put the same number in the same parentheses. So the 2 cannot go here. So the 5 has to go here, and the 2 has to go here. I check the outers. Look what I get. That 15x. I check the inners, 4x. What do I want the signs to be to get the negative 11? Which one needs to be negative, the 15 or the 4? So the 15 needs to be negative, the 4 needs to be positive. So this is where the 4 came from, this is where the 15 came from. And there we go. All of you had different teachers for Algebra 1, so you all probably learned that method a little bit differently than what I'm showing. Maybe some of your teachers showed it the same way. However you want to do that, but I want you to be able to check and make sure it's right. Okay, last one here, guys. GCF. Kate, what's our GCF?
3m squared.
Good. So I'm going to take out a 3m squared. So 3m squared divided by 3m squared. What do I have to put? 1. I see so many people just leave that blank. For whatever reason, they think it just disappears. But you got to put a 1. Minus. What's 48 divided by 3? 16m to the 4th. Okay, so now I have to look at this. It's the difference. Is it the difference of 2 squares? It is, isn't it? Because this is a perfect square. So I'm going to have to bring this down. Somebody tell me how this goes. Just say it out loud.
1 squared.
That's right. So it's 1 plus 4m squared, 1 minus 4m squared. Now I need to check again. This is the sum of 2 squares. Can't do anything with that, but can this go down further? Yep. So we have to do it. So you can see that some of these take much more than just one step. All right. Any questions over that? So that's a lot for today. So we're going to stop there.